Picture this. It's October 17th, 1989. You work for a journalism company based in San Francisco. Recently, you've been working on a paper covering the multitude of small earthquakes occurring around the Bay Area. Your boss tells you it won't receive much attention, considering how common they are in the area, but you feel like recently the pattern has been unusual. You remember back to when you first moved to the Bay Area. Your realtor told you about the risk of earthquakes, saying it was due to the San Andreas Fault, a place where the Pacific Plate and the North American Plate meet. You wonder if you might have made the wrong choice about moving. At 5:04 p.m., you and your coworkers are knocked to the floor. Another earthquake is occurring, but this is much bigger than the preliminary ones. 5 seconds go by. You've managed to crawl over to a nearby window. You're horrified by what you see. Buildings are collapsing and on fire all around you. The Marina District looks as if it was eaten up by the earth. The ground underneath has practically turned to liquid. Your seismologist friend later tells you that the term is called liquefaction. Then it occurs to you that you're separated from your family. They're still at home across the bay in Oakland. You look to the Bay Bridge to see if you can rush home after the quake is over, but to your shock, the 880 bridge has collapsed with people still on it. It has been 15 seconds now, and the earthquake finally ceases. A day has now passed. Reports have already been published that the aptly named the Loma Prieta earthquake was a 6.9 in magnitude and had an epicenter on Mount Loma Prieta, a place around 56 miles south of San Francisco by San Jose. Experts claim that it occurred due to two faults sliding past each other at the San Andreas Fault transform boundary. Unsurprisingly, your boss demands a paper on all the known damages, lives lost, and environmental damage. You don't need to do much research to convey to the extent of the harm caused. As you walk the streets of San Francisco around the rubble of fallen buildings, you notice that the line for the hospital is incredibly long. A nurse tells you they have checked in over 3,757 people with injuries, and that the first responders have uncovered 63 people from the rubble that have unfortunately perished. You're shook, but manage to jot this down in your notebook. You continue on your journey to the city government, where you ask for an estimate of damages. They tell you it will likely exceed over $6 billion. For a third source of information, you talk to an environmental scientist about the impacts of the Loma Prieta earthquake on the local ecosystem. He hurriedly tells you that the rivers near or flowing down from Mount Loma Prieta periodically increased in flow rate, affecting the ecosystem surrounding them. Additionally, he says thousands of landslides occurred in the San Francisco area. This certainly isn't surprising to you, considering how mountainous the city is. He then mentions the liquefaction of the Marina District and how the soft soil supporting all the buildings practically turned to a liquid state during the earthquake. While writing this down, you think to ask him if he knows the range of the earthquake could be felt. The scientist says it was considered moderate as far as 150 kilometers from Mount Loma Prieta. You take the finished paper to your boss, but you want to add one more thing. He doesn't follow sports very much, so you remind him that the third game of the 1989 World Series was scheduled right as the earthquake struck. The more irony was that the two teams from the Bay Area were playing in San Francisco and Oakland. Looking back now, architects and engineers have come a long way in designing buildings to withstand major earthquakes and have studied the Loma Prieta earthquake to further do so. After Loma Prieta, many tall skyscrapers in downtown San Francisco underwent seismic retrofitting, where flexible beams were added to the outside of the structure to strengthen the building. Additionally, the concept that a building should sway in the wind or in an earthquake proved to be very effective rather than the buildings that are strong and stiff, where they are more likely to fracture.